All right, so first rule of exponents, anything to the 0 power. Anything to the 0 power. Anybody know what that equals? Yeah, Rachel. 1. Okay. Anything to 0 power is 1. 1 million to the 0 power is 1. Okay, if you have a negative exponent, you will get better at this as you practice them, but they move sides of the fraction. So right now, think of that as in the numerator, right? So if you want to make that exponent positive, which is what we want to do, you move it to the denominator, okay? And it becomes positive. So that little n, that negative n, becomes positive. Now, since there's nothing left in the top, you have to put a 1. All right, so it's 1 over that. So if it was in the denominator and it was negative, you would move it to the numerator. If it's in the numerator, you move it to the denominator, and that makes it go positive, right? So this next one, it's in the denominator, the negative exponent, and we want to make it go positive. So when you bring it to the top, it changes to a positive exponent. Okay, and we really don't have to have that 1 in the denominator anymore. When you have a 1 in the denominator, it just can be x to the n, okay? Okay, a couple more rules. X to the m times x to the n. You guys probably, this would look more familiar to you, right? If you have x to the third times x squared, that's the same thing as x times x times x, 3 of them, times x times 2 of them, okay? So what does that equal to? Anyone know? X to the third times x to the second? Yeah, x to the fifth. So the rule is that we add exponents. Okay, so over here when I'm using variables, we've got the same base here, so we're allowed to add exponents only when it's the same base. So we still have an x, and we would add whatever the m and the n are. Okay, they're usually numbers, so we just add them together. And when we divide, this is pretty cool. Like, let's say I had x to the third over x to the second. How many x's in the top? We have 3. How many x's in the bottom? We have 2. How many of those cross out? 2 of them. So what's the rule, actually, when we divide exponents? We subtract. So you get x to the first, right? If you have 3 on top, 2 on bottom. So same thing here. It's always whatever is in the top minus whatever is in the bottom, so x to the m minus n. And then the last rule is the parentheses here. We have a power to a power. So when there's parentheses, there's a little bit of a different rule. Let's say that I have x squared cubed. Okay, if I'm cubing x squared, that's really x squared times x squared times x squared, right? Now that you got rid of the parentheses, you just straight up add those, right? And I get 6, like our other rule. But I could have skipped that middle step by doing what with these two numbers? Multiplying, all right? So the shortcut rule here is that we multiply. So when you have a power to a power, and there's parentheses involved, it would just be x to the m times n. How many of you guys actually remember most of those? Good. Okay, a quick review, and some of these are kind of hard, so write them down, all right? There's a couple little differences when we throw in some negatives. So I've got a -4, and it's to the -2 power. So the goal is to always get rid of the negative exponent. Right now, this whole thing, is it in the numerator or the denominator if it looks like this? It's in the numerator. This is really over 1 right now, okay? So what we're going to do is we're going to move it down to the denominator. Now, when you move it down, this negative sign is not really attached to the 4 unless there's parentheses, and it's inside the parentheses. So I'm actually going to leave the negative on the top, and I'm going to move the 4 down to the bottom, and I'm going to make that a +2. So when you move it down, it makes it a +2. What's left in the numerator, though, is going to be a -1. All right, because you always have to leave a 1 in the top when there's nothing there, plus that negative sign I'm going to leave in the top. So now my answer is actually -1 over 16. Okay. Okay, Okay, the next little problem over here is the negative is in the bottom. So in order to get rid of it, again, I'm in the denominator, so it needs to just move which side it's on. Okay, and that makes positive. So I'm going to move it up to the top, and that exponent 2 becomes positive. Okay, we don't really have to write a 1 in the bottom because it's the same thing. It's going to just be a whole number, so we can go ahead and make that 16, and we're done. Okay, let's throw in some more weird negatives. Make sure we understand what's happening with all the negatives. So we have a negative 4 in parentheses, and we've got the negative on the outside here. So when you have the parentheses, this negative is attached to the 4, so we do need to move it all together, all right? So we move it to the bottom, because right now it's in the numerator, and that little exponent goes positive. We always leave a 1 in the top if nothing is there, and this negative sign here that was not attached can stay in the numerator. All right, we do have parentheses around negative 4, so that means negative 4 times negative 4. So the denominator here becomes a positive 16, and then we still have a negative 1 in the top. Okay, so on this problem, same thing as this one, except for there's no negative sign. So can you guys just tell me what the answer would be? Yeah, 1/16, right? Negative 4 goes to the bottom, and then it squares. I do need to see the step where you show the exponent goes positive and then your answer, okay? So show the step where you're moving it and the exponent changes to a positive sign. All right, so then we're going to start doing like some crazy ones like this. Woohoo! Okay, these are fun. All right, we have no parentheses, which means this problem won't be that hard. That's always nice, okay? No parentheses. So we're going to start with the numerator. And when we're multiplying, the rule is to just add exponents. So all I'm going to do is add all my x's and add all my y's in the top first. All right, so start with all the top. What exponent is on this y that we don't see? A 1. So we might want to add that. All right, so I'm going to add the y's first. I have a 1, I have a negative 3, and I have a 5. So 1 minus 3 is negative 2, and then plus 5 is 3. So I get y to the third. Okay, so we're just adding positives and negatives. All right, now I've got my x's, so those are going to add together. So x to the 4th times x to the negative 10 would be x to the negative 6. Okay, same thing in the denominator. We're going to go ahead and combine, add like terms here. So what do I get for the y's? I have negative 6 and 10. What do you guys get? We got 4. Okay, good. And for the x's, what did you guys get? Negative 1. Awesome. All right, the next step is to get rid of the negatives. Okay, eliminate negative exponents. We don't want those, okay? I didn't want to do it in the first step because that's a lot of moving negatives around, right? So I'm going to go ahead and do it here. These two things have to switch. That's it. The ones that have positive exponents, they are going to stay where they are. So these y's stay where they are. But both the x's have negative exponents on them. So this moves to the bottom and becomes a positive exponent. And this moves to the top and becomes a positive exponent. We can simplify further. If you think of this as y over y. How many of those cancel? There's 3 on top, 4 on bottom. 3 cancel, so we get 1 left in the denominator, right? With the x's, without writing out those 6 x's, 1 will cancel. How many are left? 5 in the top or the bottom? In the bottom. Okay. So if everything that's left is in the bottom, what do we need to leave in the numerator? 1. All right. So also, the back of your book is going to have like answers not how we want them. They will have negative exponents in the answers, and we want all your answers to have positive exponents. All right. So when you're done, you want always positive. If the book has it negative, then it should just be flipped from what you have. So you can still use it to check your work, but just know that you want positives. All right. and write that down. And you might want to make a note in your notes that whenever you have parentheses, you always want to start with the powers that are on the outside of those parentheses. Okay, the parentheses first. All right, so we're going to start with powers, and these powers, what's the rule for those? What do they always do? Add, subtract, multiply, what do we do? Yeah, Ian. Yeah, they always multiply, okay? And they multiply to every power that's inside here. So this 0 would multiply to both of these, 2 and -2. And this -2 would multiply to the -3 and the 1 that's on the y that we don't see, okay? But what is anything to the 0 power? Yeah, this entire thing is to the 0 power. So this entire thing is equal to 1. That's nice. It's really nice when you have those because they kind of just go away. Because anything times 1 is itself. So we don't even really need the 1 anymore. So let's go ahead and multiply the -2, though. Very important that we do that. So I'm going to multiply the -2 to both of these powers and see what we have. So I have -3 times -2. That gives me x to the 6th, positive 6. Y to the 1 times -2, so that gives me y to the -2. The denominator doesn't have any of the powers or the things outside of the parentheses, so all we're going to do is add like terms. So we've got the x's here, x to the 4th times x to the 3rd. Those exponents add to be 7. And then we've got the y's, y to the -8 times y to the 2nd, so that gives me y to the -6. Okay, what's the next step that we did in the last problem? Go ahead. Yeah. Okay, get rid of the negative exponents by just switching which side of the fraction they are. So the x's stay where they are, but this has a negative exponent, so it goes up and it becomes positive. This has a negative exponent, so it goes down and becomes positive. Now we got rid of all the negatives. It's a little bit easier. All right, simplify again. We really are subtracting these is what we're doing and figuring out what's left over. So we subtract 7 minus 6 and we get 1. But that 1x that's left over, that extra one, is it going to be in the numerator or the denominator? Yeah, so we have an x here. All right, and then we have y to the 6th over y to the 2nd. We subtract them, so that's 4. And is that going to be in the numerator or the denominator? There are more of them on top, so they're left in the numerator. Now, your book might have this answer like that, okay? You want to make sure you just make it positive. So if you get to there somehow, just move that x down to the bottom. Okay, and it's the same thing. All right, the area of a circle is 49 pi centimeters. What is the circumference of the circle? So two different things we're using here, area and circumference. What's the formula for area of a circle? Don't everyone shout it out at one time. Yeah, good, pi r squared. Okay, and what's the formula for circumference of a circle? Pi d. I'm going to use 2 pi r, but yes, pi d would work. I'll use 2 pi r because we're going to find r here in a minute. So they're giving us that the area is 49 pi. So what we're going to do is we're going to substitute that in for the area formula. So they're giving us the answer here. So 49 pi is equal to pi r squared. Okay, if you have pi's on both sides and you were to divide both sides by pi, right, they would just cancel on both sides. So we get 49 equals r squared. And so that means the radius is 7. We take the square root of that. Normally it's plus and minus, but when we're talking about geometry and a distance here, it's just going to be positive 7. And so now it says, what is the circumference of the circle? So we're just going to plug that in. We now know the radius is 7, and that gives me 14 pi. And then, of of course, you guys would plug that in and round it 3 decimal places. All right, grab a white.